So for today's class, we're going to continue on with chapter 9. So we talked about the particle theory and how the particles are arranged in a solid, a liquid and a gas, and how the arrangement of that particles affects the way the material behaves. So in terms of its volume, its shape, does it flow, does it not, that type of thing. So the second part, now there's not going to be a whole lot of class content today because I'm going to ask you to do a couple of experiments, which I think you hopefully should be able to do at home. So all I want to talk about today is diffusion. Okay, so diffusion is the spreading out of particles to fill the space they are in. So a good example of this would be like if you were in class and somebody took out a can of deodorant or perfume or something like that and sprayed it. Okay, so somebody, assuming I would give out, let's assume this would be somebody in the back left or back right hand corner of the room, and they spray the deodorant or the perfume. Would that smell stay in the back left or back right hand corner of the room? Would it stay wherever it was sprayed? Okay, so no, it wouldn't. That would eventually reach my nose. It would eventually reach the nose of the people towards the front of the room. Might even be so strong that I have to open the door. So that idea of the spreading out of the particles to fill the space, that's diffusion. Okay, so gases are quite good at diffusion because we talked about that the other day, that's one of their properties, that they spread to fill the space. So the perfume or the deodorant or something, it might be something that you've experienced. Even dinner cooking or something like that. Like if mum or dad or hopefully one of you helping out are cooking a bit of dinner in the kitchen, it doesn't stay, that smell of dinner doesn't stay, around the oven or around the hob. It spreads around the house and someone coming down and goes, that smells good. Now, what's that? So that occurs because of diffusion as well. Okay, so in terms of theory, that's literally it. What you need is, hang on, let me get it now. Go bigger. The definition of diffusion. Okay, so then with your time today, what I'm going to ask you to do is, if possible, I want you to try and perform these two experiments. Now, they're not like full on kind of proper experiments, so I'm not going to ask you to write them out in your portfolio, but what I am going to do is I have this little document here and I'm going to ask you to answer these questions. Okay, so if you wouldn't mind writing the question into your copy and then writing the answer. Okay, where did that go? Right, so the first experiment is about diffusion in gas. So obviously we're not in a classroom, but what I would like you to do is spray a bit of perfume or deodorant or something, okay? And if you have one other person in your house, and that's fine, you have one person. If you have 6 other people in your house, see can you get them all involved and get them to stand different distances away. So if you stand with the perfume and your timer, okay, and you kind of have, I don't know, one person 1 meter away from you, somebody else 2 meters away from you, somebody else 3 meters away, somebody else 4 meters away, as many people as you have available to you, okay, and they're all kind of spaced away from you. You literally say, right, everybody ready, you spray your perfume and you start your timer, and then you wait for the first person to tell you, I smell it, and you write down the time. And then wait for the second person to say, I smell it, write down the time. Does that make sense? So essentially you're going to have a little table with, I suppose it's distance really against time. So the first person we say is at a 1 meter distance and they receive the smell after, I have absolutely no idea what kind of numbers you're going to get. I'm very interested. So say, I don't know what kind of time you're going to have, I'm assuming your phones, but let's say something like that. And then your second person 2 meters away, and maybe it takes them 4.1 seconds to receive it, and maybe that's all the people you have, in which case that's fine. And if you've more, keep going. You might get to a point where person number 4 says, "Well, I didn't get a smell." Um, you know, very possibly the smell does not diffuse that far, whatever, 4 or 5 meters. Does that make sense? So that's the first one. So we're doing this experiment, but we're not kind of following it as it is here. I'm going to make it a little bit more scientific. So yeah, that's another idea, depending on how cooperative your family are, is if this is you holding the perfume here, you could place people a meter away, but in different directions. And see how long it takes them to get the smell. Okay, and that would be interesting to see if you could make this work. So even if you only had 2 people, and instead of, so I want everybody to do this, okay? But if you have, if your family are in good form and cooperative and want to help you a little bit more, try this. So get people the same distance away from you, and see, I mean, if you just spray straight up in the air, they should all receive that smell at the same time. But sure, let's see what happens. Okay, so there's 2 little bits there to do with diffusion of gas, and then diffusion of liquid. You don't really need anybody. So essentially, what you want to do here is, and please be careful, okay? But you want hot water, like almost boiling water. So boil your kettle, pour some water into a glass, and then medium. So that would be like, water that you boiled 15 minutes ago and it's cooled down, and then cool water, so maybe tap water. I'm assuming you're not going to have a thermometer, so we won't know what those temperatures are, but they've literally just called them hot, medium, and cold here, which is absolutely fine. Okay, if you have a drop of ice, you could throw that into the cold one and see what happens there. So you'd be assuming this one would be close to 0 degrees. This one, if you boiled it and let it cool for, 15-20 minutes, you might be talking about 40 degrees, something like that. And then this one would be, if it's boiled and poured out, by the time you kind of get sorted, you might be talking about something like 95 degrees. Okay, so they're not the temperatures, but you just call them hot, medium, and cold. Okay, and then what you want to do is, if you have a little bit of food dye, drop the food dye in. You'll have your iPad, so you can take a little video of it, just so that when you're writing it back. So it says here, before the start, predict the results of the investigation. What will you do to make the investigation a fair test? Hopefully, you're all shouting at me at the moment. But to make it a fair test, we have to make sure we have the same amount of water in each. So if you're using similar glasses, make sure you fill them to the same level, or if you have a measuring jug in your kitchen, just put like 50 mils into each one. So make sure it's the same. Over here, same. So that's the first thing, and the second thing is same amount of drops of the food dye. So 2 drops is loads. Okay, and what did you observe when the food colouring was placed in each cup, and explain what happened using the particle model. So essentially, I just want to know what happened. Did you notice any difference? Did the temperature have any effect? Is that okay? So your results table in that one is going to be like hot, medium, cold, and some kind of observation. So diffused quickly, I don't know, maybe diffuse quickly down here, whatever. Diffuse more slowly, that type of stuff. So more of a word thing rather than numbers. Okay, so like I said, you've literally 1 line to take down into your copy, and what's important here is the experiments. Okay, so this one I'm kind of deviating quite far from what is written here. We're doing the title is diffusion in gas, and I want you to see, can you do one or both of these little setups and see, can you get me some numbers? And then diffusion in liquids, you need your three glasses or cups or whatever, and put different temperatures of water in them. Please be careful with the boiling water. And then you're going to put 2 drops of food dye into the water and just observe what happens. Now you have the beauty of being able to record it with your iPad, so that's handy. I would like you to do this before you start. Predict, how do you make it a fair test? I've given you the answer to this, and then basically just tell me what you observe. Okay, so don't worry too much about explaining it. Okay, and all the while, keep your homework in mind. 5 pretty simple questions, I think, that I want you to answer. Okay, so hopefully all that takes about, it shouldn't even take you an hour, I don't think, but like if you can get people to help you. If you can't, if you really can't get anybody to help you, and you don't have food dye, whatever, if there's no way you can do these experiments at home, perhaps somebody who can would be kind enough to record it and send it on to me, and I can share it with whoever. Alternatively, if you go on to YouTube and Google like diffusion in liquids, you'll see some experiments there. Okay, so hopefully it's literally just some water and a bit of food dye for one experiment, and it's literally just a spray of perfume or deodorant for the other. So hopefully you'll be able to do it. All right, have fun with that.